Okay, so we're recording now. And as I said, I'm going to answer the questions I got by email and on Canvas first, and then we'll open it up for general questions. Before I get going, anyone have any comments or questions not technical? Okay.
I have a question about case study. Well, the next case study okay. 4.
Okay.
When we implement the operators and we set the capacity into, we use just the default configuration. We don't worry about anything else in that sense.
One more time, when we do the operators and we set the capacity, what's the question?
So when we set the capacity to and set the requirements for the operators, we just leave everything else in the default setup for the operators. We don't worry about any.
I guess I'm not sure where you're going with the question. So what I'd like for you to do is experiment with it, and then you tell me, do we need to change anything? Do you want to do prioritization or any of that? What I was saying in the assignment was that I wanted you to use this pooled strategy where you have 2 operators and either one of the operators can do any one of the setup tasks. And then I was saying the simplest way to do that is by using the capacity too. But you can also do that using separate operators and using a list to select between the 2.
Okay, so it's like open for us.
It's open. Yeah,
okay.
I want you to implement the pooled strategy, but there are multiple ways to do the pooled strategy. I just gave you the simplest.
Okay, thanks.
Okay, so I'm going to stop video, share my screen here. Let's get it all set up. Let's see here. I want to share my screen. I want to share this screen. Can you guys see my screen and all?
Yes.
There's nothing on it other than Zoom camera.
Yeah, a blank slide.
Okay, so I got a few questions here. The first one has to do with the edit the data files, or must the model be able to run with the data files straight up from Canvas? I added an extra column in the material table to perform the sequence dependent setup. So I want to talk a little bit about this one and go through an alternative that I think would be preferable. To answer that specific question, if you didn't look at it on Canvas, what I said was, you can modify the data table if you'd like, but you also have to provide a mechanism for me to modify the data table. So when you guys turn in your assignment, for example, one thing that we might do is, run the model on data that you haven't seen.
What?
Okay.
Yes.
Does someone have a question about that?
I have to know how it works.
And is that a question for me? Okay, so let's talk about how this works and what I think I'm going to give you this alternative strategy for doing that. And so what you see here is the case study 3. And as you remember in case study 3, we have this finish station and we have the sequence dependent changeovers there. And so what we gave you was we specified the module name here as the foreign key property, and then the color as the list property. And we use that color to do the sequence dependent changeover. So go look in the definitions, finish changeover logic, and look at the row here. And what you saw was that we were using that orders color to be the transition for the sequence dependent changeovers. So the question was for case study 4, now we have this other distinction between module class ABC and XYZ. And the question was, could you insert a column here and then specify in the column which one of those list attributes it is? And my comment was that since you don't have direct control of the input files, I mean, you do for these specific input files that I gave you, but again, if we want to run your model on a different set of files, then you have to provide a way to update the data file accordingly. So some kind of a program, a Python script or something that says, okay, run this first so that it updates the data file. So for this case, that would not be my recommendation. So it'll work, again, it'll work. And in a situation where you have total control of the data files, so let's say you're building a system that does daily or weekly scheduling and you control the connection between whatever your master planning system is and your model, then you can use that mechanism because you can create the filter so that the data files work automatically. But this isn't that situation because we are in control of the data files. And so that makes that a little bit more awkward. So as an alternative strategy, what I suggested was that you use an entity, state. And so if we look at our facility view and remember how this model works, when an order arrives, we create an entity, we create an order entity, and that order entity has a reference to this order table. And it's that reference to the order table that lets us look at these things like the module name and the color and the paint and so on. And so when we create that entity, though, we still have access to all of that data, right? So this entity is going to have that row reference. So another way to do this, to do the same thing, is if you go in data and look at your changeover matrix, you're obviously going to create another changeover matrix that goes from XYZ to ABC. But what I need to do, and what I'm going to eventually have to do, is create a list. So I'll just go ahead and create this list and call this a string list. Let's call this module class, and we have two values. We have ABC and we have XYZ. Okay, and how Simio implements lists is it's this list of, in this case, strings, and what's key here is the index here, index 0 and index 1. And so when you use a list element, what you're doing is you're creating an integer state. And so when I say string module class ABC, that's going to equate to 0. And string module class, list module class XYZ, that's going to equate to a 1. So if I want to use an entity state, I can go to my entity and say, let's just create an integer state. We'll just call this module class. And now I have an entity state to store that information. Okay. And so I can go back into my model, and as an add-on process for order arrivals, when an order arrives, remember it's going to have a row reference to that table. So I'm just going to go to my add-on process trigger here and say, when I've created an entity, so now this is going to get executed whenever an entity is created, and the associated object of the token is that entity. So I just need to make a decision, and my decision is this a module A, B, or C, or is it a module X, Y, or Z? Okay, and so this decision that I'm going to have is going to be condition based, and it's going to be the decision. If I want to say the true branch is ABC, I'm going to say is orders module A or module B or module C, and then I'm simply going to assign that value. So I can go and say what I want to assign a value to is model entity module class. And then here's where I can use the string. So just pull that up, and I want to do list module class ABC. And so this assignment is going to say if this decision is true, which is just that decision of whether it's A, B, or C, then I'm going to assign module class ABC. Otherwise, and I'll just copy this one. So Control C, Control V, and then go change this one to the alternative X, Y, Z. Now, when the entity has that state information, so the model entity.module class will either be value ABC or XYZ, corresponding integer value to that. And then I can go back into my element when I create my changeover, right? So when I create the corresponding changeover here, instead of having this reference be orders.color, it would just be model entity.module class. Okay, so instead of reading that state transition information from the table, I'm reading it directly from the entity. Okay. So then, of course, you have to build the expression for the decision, but it's pretty simple. It's just orders.mname. What did I call that? What did I call that in the orders table? Orders table mname. So it's either going to be orders.mname equals C, or orders mname equal B, or orders mname equal C. Then it's true, and I make that assignment. Okay, and then just remember when you do the changeover matrix, instead of using the table row, the table reference, you're just going to use that model entity reference. Okay, does that make sense to you guys?
Yeah.
Anyone have any questions about that? Okay, so also note that you also have to set priorities here. So once I have this decide module and I'm sitting, I'm going down this branch, I now know that I have an ABC, and when I'm going this branch, I have an XYZ. So I could also assign my priority here, right? So there's a built-in entity state called entity priority. So if I wanted to, I could just go right in here and say entity priority equal whatever you want the priority to be. Maybe this one's priority 1 and this one's priority 2 or something. So once I've had this logic to distinguish between which class I'm in, I can use that. That line of the process to make any kind of modifications that I want based on module class. Okay. Okay, so that's question 1. Question 2 is a little bit more kind of general, so there's no semio involved in this. It's what are some strategies we can keep in mind when we do V&V, validation, verification for the model in case study 5. Specifically, what are some ways that we should be thinking about approaching V&V for the foundations of the model? And well, I guess I don't need to read the whole thing. As an extension, could you please discuss the extent of V&V for case study 5? Okay, so I want to talk about this just a little bit. And we think about, first of all, the question was about V&V, which is validation and verification, but all we're doing here is verification. We're not doing any validation, because validation is where you make sure that the specifications match reality. And for this assignment, there is no reality. So Obby Electronics doesn't exist. And so it's not validation, because I'm giving you the specifications, and so it's just verification to make sure that your model matches those specifications. Okay, so the nuance between verification and validation. So the idea here, let me pull up this assignment here. This is the assignment for case study 3. When you think about verification, what you're doing is you're ensuring that the model works as expected. So if you look at this model, we have 3 different module types, and they go through these 4 processes: kit, assemble, finish, package. So you questions like, well, how do you know you've implemented the sequence correctly? In other words, how do I know that the modules go from kit to assemble to finish to package? How do I know that I've implemented these times correctly, right? So I might go from kit to assemble to finish to package, but how do I know that I've set this up correctly? Like when you watch the video, in the video, if I'm not mistaken, I made the mistake here of forgetting to multiply this one by the quantity. So I said, well, what's the time? Well, we have a setup time, which is 15 minutes for module A, the processing time, which is 10 minutes, and the finish time, which is 10. But this processing time was supposed to be by quantity. So it was supposed to be 10 times the order quantity, and I forgot that part in the video module. So the process of verification is saying, well, how do I know I have done that? So how do I know that I've implemented this correctly? Sequence dependent changeover. So you can build this, the changeover logic element, but you can have a mistake in it, or you could apply it incorrectly so that you don't actually have these sequence dependent changeovers, so that when you run the model, it runs perfectly well to the end, but it's just not correctly implemented. So you don't see these sequence dependent changeovers. Same with material consumption. So somewhere in here, I have module A. So module A takes component A, 2 component Bs, 4 component Cs, and kit. Well, how do you know that you've implemented that correctly, so that when the module goes through the kitting operation, it actually consumes those materials? So it consumes 1 of these and 2 of these and 4 of these, rather than 1 of these and 1 of these and 1 of these, or something different than what the specification is. Okay, and so that notion of verification is saying that I'm going through the model and demonstrating that it does, again, what I've specified for it to do. That's what verification is. Okay, and so keep in mind, when you look at verification, you're collecting evidence for a process of convincing. So you're trying to convince yourself, and you're trying to convince me that your model works correctly. In the real world, you're convincing your boss, or you're convincing your customer that the model works correctly. And verification on complex models is very difficult, or generally impossible, to prove. So you're just collecting enough evidence until you're convinced. Okay, does that concept of verification make sense? So some ideas about how to do that. I mean, you use sample data. So you do purposeful experiments. So for example, if I want to demonstrate that, you know, the times are correct, create an order with quantity one, create an order with quantity two, a single order, and then show what these times are, show how the times are computed, either show the Gantt chart or show the actual times to say, if I have, say, module A with 10 modules in the order, that I spent 15 minutes on setup, and then I spent 100 minutes on processing, and then I spent 10 minutes on finish, right? Show that. If you want to do the sequence dependent changeovers, force a sequence dependent changeover. You know, I think in this model, we have 3 finish stations, right? So create a set of orders where you have 3 red ones and then 3 blue ones. And that should get you at least one sequence dependent changeover that when you look, you can see it. So I can see when I transition from one module of one color to a module of to a module of another color, that I actually did have that that changeover. Okay. And so what you have to tell me, what you have to give me when I say for this report is, okay, tell me exactly what you did, right? So, you know, I set up an experiment to show this, and here's what I did, right? It's just a sequence of how you came across, you know, how you convince yourself that it's correct. And what you guys can do, and we're in a classroom setting, is you can, you know, ask someone else in the class, is this what you got? Is this what you got? And, you know, so that gives you some comfort that your model's correct. If you get the same answer, there's no guarantee that it is, but it gives you comfort. But in general, you don't have that. You know, you're doing a model that doesn't exist, and so there's no one to compare it to. And so you have to go through this verification process. Okay, anybody have any questions for me on that? And so in terms of the extensiveness, what I expect to see, well, what I expect to see is that you've demonstrated that your model works. So you have all of these different aspects, from sequence dependent changeovers to material consumption to material production to then this, for case study 4, the second set of sequence dependent changeovers. You have all of these things, and what I would expect in your verification report is that you've demonstrated how you know that you've correctly implemented all of these things. Okay, anyone have any comments or questions on the verification question? Okay, onward we go. Okay, another kind of general question that really has to do with how do you get started in model building. So the question specifically requests, once you have already done a conceptual design, so we understand what the real world problem is, and we've outlined the structure of the model. And so that outline the structure of the model is what I would refer to as conceptual design. So I'm taking the real world problem and conceptualizing it in terms of my simulation model. What's the best place to start? Well, this really is a matter of experience and personal preference, right? The more models you build, you develop a preference of, do I start with data? Do I start with structure? Do I start somewhere else? Right. And so there's no prescribed way to do that. Personally, I generally start with the data. So if I have a model that is similar to something that I've done in the past, then I try to draw on that experience and say, okay, let's build some data structure, some table structures, especially if I'm going to use auto creation. I'm going to build the table that creates the entities first, and then go through and sequentially add things to that model. And the specific part that I try to do is every time I add something new, do some verification, so that at the end, I'm confident about my entire model. But that structure sequence of how you build it, again, based on your experience and your personal preference. Kind of the second half of this question has to do with building models with problem-specific scheduling or future generality in mind. And so again, that really depends on 2 things: your experience and then some expectation of future projects. If experience tells you, I've done something like this before, then you're going to reach into your toolkit and use some of those general tools that you've developed, and you might add additional tools based on this particular project. Similarly, if you know that you're going to have, say, phase 2, phase 3, phase 4 of a particular project, you want to look at generality. If you're doing something brand new for the first time, it's really difficult to think in general terms because it's all brand new. Okay. All right, so those are my general discussion questions. A little bit more specific now. So this one says we are given that in order for the new modules, the modules will be packed at the assemble station immediately after assembly. They do not visit finish or package station. Considering this, do we need to use a new sync to destroy these modules, or can we destroy them at output and assemble? You can do either, right? So if you look, there are a lot of ways to do this, right? There are a lot of ways that I could have the new module stop right here. As was suggested, I could create another sync, but I could also go to this sync, right? Because remember, our implementation that we use here is we use the sequence table. So we use routings. And so if I go look at my routing here, let me do the routing from here. If I do module A, you know, module A goes from kit to assemble to finish to package to ship. I could just as easily add to this table a module X that goes from kit to assemble to ship. Right, then I haven't added any new stations. They all go through the same ship station. I could have a second ship so that I could track between, you know, the module ADC and the module XYZ. And so you could use some of the automatically collected statistics, right? Remember that the sync node, sync objects automatically create time and system statistics. So if you separated those into one ship for the ABCs and one for the XYZs, you'd get additional information. So from the perspective of the assignment, it doesn't matter to me which mechanism you use, as long as it works and that it you know, implements the basic routing. Okay. Mimi, you asked this, and I saw that you were on. You have, does that clear up your question?
Yeah, that's clear. Thank you.
And I have two more. If we use either way, so this is the previous thing. If we use either way, defined for the new modules, how can we compute the performance metrics such as average time in system? This is really a question for you. So part of the design is figuring out, okay, what's the most effective way that I can compute what I want, right? If your objective is time in system by module type, creating a second sync's the easiest way because there's no more work to do. But you can also do time in system by module type if you use one sync, right? You just have to use that decision of the module class to manually record the tally, right? So you can get the information either way. You could also do it if you destroy the entity at the end of the assembly station, you could also create a tally. So it's really not so much of, you know, choosing one and how to do it. It's okay, based on what I want to compute, what's the easiest mechanism to implement it? Okay. And then lastly is for the changeover operator, do we need to have must simultaneously seize option true? And once again, this is a question for you. So should you or should you not? Well, you should try it. What's the impact, right? So I assume the root of this question is when we're doing the, when we need the secondary resource, you know, we have two resources. You have a station and then you have the operator. And there's a must simultaneously seize option that basically says if one's available and the other one's not, don't seize it. And the default behavior is seize one and then seize the other. And so if you use that default behavior and you seize the first one and the second one's available, then you're blocking because you're still holding the first one. If that becomes a problem, you will see it, right? So if you execute your model and you have this situation where, okay, the changeover operator is not available and I'm just sitting at a station waiting, you will see that. You know, you will see that in the results of your model. And that's where you would go back and say, well, let me see if I can change this by having maybe this must simultaneously seize, or by, you know, updating the constraint logic that we saw before when we did the materials or so on. That's part of the planning process, is saying, I want to achieve a particular goal. I'm seeing something I don't like waiting for a secondary resource. How do I fix it? Okay.
Okay, thank you.
And that is all the questions I got by email. So if anyone has any follow-ups or totally new questions, now's the time. If you want to share something on your model, now would be the time. No one has any other questions for me? No one wants to see anything else, discuss anything else? Guys are a quiet crowd.
I don't know if we could have another session like this one next week. It's because we just started working with case study 4, and for real, like I'm not sure.
Yeah, I'm happy to have another session if we have it. I mean, as I said in class, you know, I have some more topics that I'm going to cover that I'd like to be able to cover for the course, but all of the semio concepts that you need for case study 4 and 5, we've covered. And so since these two things combined are a big chunk of your grade, I'd like to see everyone do well. And so I will spend as much time as we need to talking about the case studies, answering questions, and so on. But you guys have to come with those. You have to come with questions or say, here's what I want to talk about or something like that. And so based on what we do Tuesday in class or what I get over the weekend or, you know, between now and Tuesday, I'm happy to do the same thing again next Thursday if we choose to do that.
Yeah, thank you.
Okay,
Dr. Smith, I have one more question.
ask away.
In here, for the new modules, we use shipping thoughts, and they are reusable and they are returned back to the.
I can't understand you, Mehmet. What? One more time, talk a little louder.
Okay, for these new modules, it is explained that we use shipping thoughts. So in the model, do we need, will we need any combiner and separator for this? And
Well, I mean, what are you thinking would involve a combiner and separator?
because they will be carried by with shipping thoughts, and then they will return to the, since they are usable, reusable.
Yeah, but I also said in the assignments, you can totally ignore the shipping totes.
Oh, so time, yeah. So,
Yeah, so you put them in totes. And so let's say that you are going to then have to do something with them after they're put in the tote. Yeah, then you're going to have to figure out how to deal with the tote, but you can totally ignore the tote for this one.
okay.
We're also not creating individual modules. So if an order was for 20 of these, you know, module X's, let's say, you're not creating 20 entities that would need to be combined. You have one order entity, and that one order entity is being processed as a batch. So you see it as one thing, even though there are really 20 of them. If alternatively, we were going to create 20 entities so that you could say, maybe do some kind of flow line so that you don't move them all as a batch, but maybe you have like one piece flow, then you would need some kind of combination logic so that once you finish processing all of them, you would combine them into one entity. But since we're not doing that in this model, we're just using one entity to represent the whole batch.
Okay, thank you.
Sure.
Thank you for the clarification.
Anything else? Going once? Going twice? Okay, continue to ask questions on Canvas. Again, let me know if there's something you want me to discuss in detail. Depending on what we do Tuesday in class, I am happy to schedule another one of these on Thursday. Or if anyone who's not here because of scheduling conflict is watching the video and wants to propose another time, I'm happy to also have this at a different time. So just let me know. Okay. All right. You guys all have a great rest of the week and a great weekend.
Thank you. You too.
Thanks. Bye.
Bye.
Thanks.